Hi everyone, so we're going to continue with our last part of our water notes, starting with the acidity of seawater. So you might know that acidity is measured in pH. So the pH of seawater is going to change with its depth here. So as the further you go down or the farther you go up, we're going to see that difference in that pH. And this is going to be due because of the amount of carbon dioxide that you're going to see within the water. So carbon dioxide, you get different amounts with photosynthesis and respiration. So photosynthesis, we use carbon dioxide, and respiration, we give carbon dioxide, so we put more into the atmosphere. So carbon dioxide is dissolved in water as carbonic acid, which is going to affect that pH of the water. So in areas where we have less photosynthesis, like our aphotic or our benthic zones, we'll probably see a lower pH because of this carbonic acid. So the water is actually going to be more acidic the deeper we are because there's less photosynthesis occurring to take that carbon dioxide out of the water. So as we see, photosynthesis and respiration here in our different levels, like we saw, our photic zone, there's high amounts of photosynthesis happening because of that light. So that photosynthesis is going to remove that carbonic acid. And we're going to see our pH be kind of neutral with around 7. Excuse my dogs in the background. So in our next level, we're going to see that there's less light available, so there's less photosynthesis that's happening. That means there's going to be more carbonic acid, and our pH is going to be more acidic. And then our bottom letter, our aphotic zone, our benthic zone, we're going to see no photosynthesis occurring, which means the pH is going to be even more acidic in these regions. So a lower pH, so from 1 to 7, is more acidic. So I'd say probably here we'd have I'd say 4 to 5 level, and then down here we can have between maybe a 1 through 3. So as we decrease photosynthesis and increase respiration, that ability to have kind of a balance between photosynthesis and respiration here, we're going to see a neutral pH. When we see less photosynthesis occurring, but still the same amount of respiration, we're going to see a slightly acidic pH. And then where we see no photosynthesis with still the same amount of respiration occurring, we're going to see a very high pH here. So next thing we're going to talk about is sound. So sound is going to travel 5 times faster in water than it does in land. So because of this, marine mammals use this thing called echolocation. And it's a sense the object's distance, size, density, and position in our water. So a lot of mammals that use this is going to be one that you're super familiar with is the beluga whale, but also dolphins and other animals are also going to use this echolocation. So sight is usually not something that's very good in water, but sound, since it travels so quickly, this echolocation gives a lot of information about what's in the water in front of them. So if you can see here, we're sending out a signal. It's going to bounce off our fish here and send a signal back to our dolphin to give them all information about size, distance, density, and position. Next thing is pressure. So pressure is exerted by water. That is going to be called hydrostatic pressure. This is due to the weight of the water. So as we go down into the ocean, our pressure is going to increase because there's more water, more weight on that ocean. So an organism who lives at 10 meters or 33 feet under the water is going to experience twice the pressure that is present at sea level. So as we go down in the water, our pressure is increasing. So let me add that, pressure increasing. Next thing that we see with animals is sinking. So since there's a little bit of pressure and usually you sink when you go into the water, there's a few things that organisms have to avoid this. And that can be plumes, hair, ribbons, spines, and other protrusions. So if we take a look here, we see quite a bit of protrusions on these two animals, and that's going to help prevent them create more surface area and have other buoyancy things. So some other buoyancy adaptations is going to, this is going to allow them to stay afloat in the water. So some animals have swim bladders. So this will fill with gas and help the fish rise or deflate to lower. And we saw that with that animal in our video who can kind of move just by pushing water in and out of their shell. So those are a bunch of different buoyancy things to help that these animals grow. So again, plumes, hairs, ribbons, spines, any other protrusion. And then we also see these swim bladders, which is another adaptation to help prevent from sinking. Drag is another thing that animals are really going to have to overcome. So drag is just this pushback with the water. Since water is a lot more dense than the air, there's a lot more drag within water. So some adaptations, animals might be shaped differently. As you can see in these three pictures, we have really nice shapes that help reduce that drag with those streamlined bodies. We also see that some animals might excrete mucus or oil that's going to lubricate their bodies to help them slip through the water, which will be another thing that's going to help with that drag effect. So as you can see here, this animal, when it's upright like that, is going to have a huge drag and have to use a huge amount of energy to get through the water. This one is less because it has less of a surface area, but this one is definitely the most proficient because of that streamlined body here. So that is where we're going to end with our water characteristics. If you have any questions, please feel free to reach out.